Hi, this is Professor Fernandez, and this is video 1 in lesson 22. It's actually video 1A because we're going to be talking in this video and in the next one, video 1B, about trigonometric functions. So I'm going to do that in the context of this example that I've written up. It's not quite from Calculus Simplified, but it is related to it, specifically around figure B.20 in Appendix B in the book, where I am introducing the notion of amplitude, period, and midline of trigonometric functions. So let me just remind you what those three terms mean, and then we will go ahead and do this example where we want to identify those three aspects of these three trig functions. Okay, so here is a run-of-the-mill sine function that you might run into throughout this calculus course and certainly in subsequent math courses. Each one of these numbers means something, and it has an implication for what the graph of this function looks like. So let's go through each one of these numbers. Let's start with C. So this is called the midline. And long story short, the midline is the y value that cuts the graph of this function in half vertically. So for example, let's start with the graph of sine x. Okay, so that looks kind of like this, right? And it repeats every 2 pi. We'll talk about what that means in terms of these numbers ABC in a minute. So if I did, and I should say it ranges from -1 to 1 in the y-axis. If I did y equals sine x plus 1, then this would be the same graph of sine that I just drew, but it's shifted up by 1. So 1 now becomes the y value that cuts this graph in half. Okay. So you can see that all I've done, and you might already know this from your transformations of functions back from a pre-calculus class, for example, all I've done is that I've taken this graph up here and I've shifted it up by 1 unit. You can see that the original graph had a midline value, C of 0. Okay? The new graph has a midline value, C of 1. And so you can see in my characterization here, because C is 0, that y equals 0 line cuts the graph vertically in half, right? So half of the graph is up here, half of the graph is down there, okay? Over here, the midline of 1, y equals 1, it cuts the graph in half, right? So half of the graph is down here between 0 and 1, half of the graph is up here between 1 and 2. Okay, so that is the midline. So let me now talk about the next value, and I'll keep these graphs up to refer to them. The next value of interest over here, so see if I can erase, well, I can erase most of it, that's great. Maybe not that one. So the next value of interest is that I'll talk about is A. So what is A? You might think of A as the amplitude, and that's very close, but it's technically not correct. So the absolute value of A is the amplitude. Why absolute value? Because we're thinking of the absolute value of A as a positive number, right? So absolute value, or at least 0. And that is the amount that we add above the midline and subtract below the midline to get to the maximum and minimum of the graph. So for example, over here, there is a hidden 1. So A equals 1 in the sense of whatever is multiplying sine equals 1. And also absolute value of A is the absolute value of 1, which is 1. So in this graph, the amplitude is 1. And what does that mean? Well, like I said earlier, you start at the midline, y equals 0. Remember we said y equals 0 is the midline here. And then because the amplitude is 1, you go 1 above the midline, and that is the highest that the graph will ever reach. Okay? And then you go 1 below the midline, and that is the lowest that the graph will ever reach. Same thing over here, right? There's a hidden 1 here, so once again, A equals 1, so the absolute value of A is 1. Similar idea then, the midline is still 1, so you start, the amplitude is still 1, so you start at the midline, which also happens to be 1 here, and then you go 1 above, and that takes you to the highest point on the graph, which is 2. And then you go 1 below, and that will take you eventually to the lowest point on the graph, which is 1 minus 1, 0. Okay, so that takes care of 2 of the 3 numbers that help you understand how the graphs of sine, and we'll talk about cosine in a minute, basically the same idea, differ. So let's talk about this third number. What about B? Okay, so let's talk about B. So I'll actually start first talking about something that's related to b. So let's talk about t, the period, which is defined as 2 pi divided by b. So t is the period, and that means that it's the number, it's the length of one cycle of the graph. So for example, if I look over here at sine x, right? This is really sine of x, and there's a hidden 1 times x here. So b equals 1. So that implies that my t is 2 pi divided by 1, which is 2 pi. So what does that mean, right? What does it mean for my period to be 2 pi? Well, it means that if I start at x equals 0, I have to go 2 pi units before the graph repeats a full cycle. And you can see that here. I start here, I go up, I go down, and then eventually after 2 pi I get back to where I started. You might say, no, wait a minute, you started here and you got to x equals 0 here, right? Why isn't the period pi? And the answer is because that is not a full cycle of the graph, right? This is a full cycle of the graph. In other words, the graph is not just this, right? It is this. That's a full cycle. So that full cycle takes a unit of 2 pi, a length of 2 pi units to repeat. Same thing happens over here because we have not changed the b value, right? So b here is still 1. So t is 2 pi over 1, which is still 2 pi. So even though this graph looks a little different because of the midline, the period is the same. I start at x equals 0, and I have to wait 2 pi units to then get back to the same point I started at after one full cycle. Okay, so now then, what is b? Okay, so b, if I erase all of this and I go back to this example, b is what's called the angular frequency. So let's put it up here. So if t is the period is 2 pi over b, okay, then that implies that b is 2 pi over t. And you can understand this kind of in a different way, right? You can also understand that as t times b is 2 pi. So if t is like how long it takes for one cycle to reach the length of a cycle, of a full cycle, then b is kind of like how many cycles there are in an interval of length 2 pi, right? That's literally what this means. You get 2 pi and you divide it by the length of a cycle. In other words, how many cycles there are in an interval of length 2 pi. So let's go back to our example. So sine of 1 times x, that tells us that b equals 1. This tells us that if I draw any interval of length 2 pi in the x-axis, then there will only be one cycle that fits in that interval. So that's an example. Here's an interval of length 2 pi, right? From here to here is 2 pi units. Sure enough, there's only one cycle that fits in this interval. If I drew a graph of, for example, y equals sine of 2x, well, then the b value here is 2. So to draw this graph, here's 2 pi, here's pi, I would start at 0, but instead of going all the way out to 2 pi before repeating the full cycle, right? Instead, I go all the way out only to pi. So at pi, I have to repeat the full cycle. So I kind of compress the graph a little bit. Okay, and that tells me that in an interval of length 2 pi, I can then do another cycle. And then how many cycles have I done? I've done 1, I've done 2. 2 cycles have been squished into an interval of length 2 pi. So that's what the b value means. If this was 10, then I would have to squish 10 cycles in an interval of length 2 pi. That would take a very long time. And eventually, I get to the last cycle, and this is a length of 2 pi. So that's how you interpret the b value. You might be wondering, what happens if I have a negative sign here? What about, sine of minus 2x, right? How would I interpret the b value there? Well, remember that, oops, I'll just phrase it this way. Remember that sine of x, or sine of negative x, equals negative sine x. You might know this as sine is an odd function, or you might think about this in terms of symmetries of the graph, various ways to think about it, but that can be used here to then write this as negative sine of 2x. Okay? So what we learn from this is that any negative b values, any b values that are negative, that negative sign comes out in front and ends up affecting the y values of the graph, and then it leaves the b positive. So then once again, you can go back to an interpretation like we had over here in all these different graphs. Great, so we have now talked about every single parameter that could possibly matter for this sine graph. I will tell you that it's the same exact interpretation for the cosine graphs. So if it's a times cosine bx plus c, similar thing. This is the midline, the y value that cuts the graph in half vertically. The absolute value of this is the amplitude. You add that to the midline to get to the highest y value. You subtract that from the midline to get to the lowest y value. And then b over here, this is the angular frequency. How many cycles fit in an interval of length 2 pi? And then the period t tells you how long each cycle is in terms of its length on the x-axis. Okay, awesome. We have covered all that. So now let's put it into practice in this example. So let's identify the amplitude, the period, and the midline of each of these functions. Zoom in a little bit here. So now we see that if I fit this into the a sine bx plus c form, a here is 3. The absolute value of 3 is 3. So that is the amplitude. Great. B here is 4. B is 4. That's the angular frequency, but we were asked to identify the period. So that tells me that the period is 2 pi over b. That's pi over 2. That's the period. And then C, the midline, there's nothing being added here, so there's a hidden plus 0, so C is 0. So if I wanted to graph, just to review what we just talked about, if I then wanted to graph this function, what would I do? Right, y equals 3 sine of 4x. I'll only do this once to get to the other examples and keep us on time here. I would say, okay, so first 0, y equals 0 is the y value that cuts my graph in half vertically. Great. And then a equals 3, right? So I'm going to go 1, 2, 3 units above, 1, 2, 3 units below. And that's going to be the maximum extent in the y-axis, y direction of my graph. Great. And then in terms of the period, pi over 2. So each pi over 2, I get a repetition of a full cycle. So my graph is going to go up to the maximum, down to the minimum, and back to pi over 2. Up to the maximum, down to the minimum, and back to the next pi over 2. So pi over 2 plus pi over 2, that's pi. And then let's see if I can erase. Great. Awesome. And then I do another one of these. And I'm at another pi. So this is 3 pi over 2. Another pi over 2. I do one more, another pi over 2. I'm back to 2 pi. Up to 3, down to negative 3, back there. And then you can see I have traced out 1, 2, 3, 4 oscillations. That is the angular frequency, right? 4 oscillations in an interval of length 2 pi. So that's how you would graph. And then, of course, copy and paste this graph, right? It goes this way, and then it keeps going forever that way. Awesome. So next example, let's take a look at this one. So we have an a value here of negative 2. So that implies that absolute value of that is 2. That's my amplitude. We have a b value of pi. So t equals 2 pi over b there. Tells me my period is equal to 2. And then c is my midline. There's nothing here, plus 0. So c is 0. So that's my midline. That's my period. That's my amplitude. Again, we could graph this, right? I won't do that now, but you can follow the steps that I did over here to generate your own graph of this function. And then the last one, we're looking here. So it's written a little differently from our standard form that we've been working with in this video. So let's write it this way. Oops. There we go. That should be the 2. And then we can identify, once again, there's a hidden 1 here. So that is the a value. It's already positive, so the absolute value of 1 is 1. That's my amplitude. And then the b value, that's up here, b equals 5. So the period is 2 pi over 5, which is just 2 pi over 5. Okay, nothing to simplify there. And then the c value, there is a c value here that's not 0, so that's the plus 2 here. So c here is 2. So this graph, if you wanted to graph it, I won't do the whole thing, but you start off at y equals 2. And then the rest of your graph is going to be cut in half vertically around this y equals 2. Okay, so that's just been a quick little review of how you identify the amplitude, period, midline, and we also did the angular frequency, like 4 here and pi here and 5 here, for trigonometric functions, sine and cosine, and what they mean.